Okay, so in class, some of you were able to get through exercises 1 to 6 and problem set 1 to 4. Some of you were not. Some of you got part of it done, but let me use this video to go over the answers to 1 through 6 and problem set 1 to 4. Now, I'm not going to write down all the problems, the questions. So what you're going to need to do is you're going to need to pull up S.40 through S.43 on your own. And then when you do that, then you'll see the questions, you'll see the work that you did, and you can maybe see where you went wrong, or went right. So let's move over to the paper, and let's look at what we got right and got wrong. Okay, so question number 1, number 2, and number 3. So first of all, we're just going to write the answer to number 1. I'm not going to work this one out for you, but the answer was 1.672622 times 10 to the negative 27th kilograms. And number 2 was 9.1093821 times 10 to the negative 31 kilograms. Now the first, this was the mass of a proton, and this was the mass, so this was a proton, and this was the mass of an electron. Now notice that when we're negative, that these numbers, that this is the bigger thing. This is a proton is the bigger thing because we have a bigger exponent, right? Negative 27 is larger than negative 31, so a proton is a bigger thing. Electron, remember, it had like 30 zeros, and a proton had only 27 zeros. When you were doing 0.000000001672662, whatever, that was the proton. So the proton is clearly the bigger thing, and so you should know how to do those conversions. Remember, because the number is between 0 and 1, when between 0 and 1, numbers in scientific notation have negative exponents. Right? These are very small numbers, less than 1, so they have negative exponents. Okay, so that's the key to number 1 and number 2. Most of you got that right, or if all of you got it right. Now, writing these as a ratio simply means to write these the bigger one over the smaller one. So it says, let's compare the mass of a proton to the mass of an electron. So you simply are going to write 1.672622 times 10 to the negative 27th divided by 9.1093821 times 10 to the negative 31. And that's the answer when you write this as a ratio. You don't have to do the ratio. You don't have to do the division. You're done. This is a ratio. A ratio is a comparison of two numbers using division. Whoops. Well, that went weird. Using division. Okay, so that's your answer to 1, 2, and 3. Now, for number 4, I said round to 2 digits. And now what it wants you to do is to take the numbers from exercise 3 and put them and divide them in exercise 4. So we're going to get, and we want to compare the proton, which is heavier, 1.6 times 10 to the negative 27 divided by 9.1 times 10 to the negative 31. So this is simply it says how many times heavier? Well, we know this is way heavier because we have 10 to the negative 27th is way bigger than 10 to the negative 31, way bigger, 10,000 times bigger. But let's figure out exactly how much bigger. And so what we do is we're going to divide, well, whatever, divide those and subtract those. So we get 1.6 divided by 9.1. Well, you're not allowed to use a calculator on this test, so we go 9.1 into 1.6. Well, we're going to move our thing over, or move our decimal over, and so we get 91 into 16. I'm going to rewrite it here, and our decimal is going to go here like this. So now we're going to put our 0 here, and when we divide, we get a 1. We come our 91, and we do our subtraction, and we get, 69, 90, and then we get our 7. You can verify all this on your own. So that's 7, 63, and we get whatever. This is 3, 8, 53, 530, and then we get like a 5 here. Okay, so we know, and we're rounding this whole thing to 2 digits, so we go on and on and on, but we're going to stop here, and we're going to use these numbers to do our rounding. So 0.175, if we round to 2 digits, is 0.18. So that's the answer to the first part, is 0.18. And the answer to our second part is 10, and we have to subtract these two numbers. We have to subtract our exponents. So here we're going to say minus 27 minus negative 31. Well, we're going to add, subtracting a negative thing is the same thing as adding a positive. So negative 27 plus 31 is equal to a positive 4. So our answer is 0.18 times 10 to the 4. However, we are not done yet because this is not in scientific notation. 0.18 is the same thing, and so this is not between 1 and 10. So 0.18 is the same thing as 1.8 times 10 to the negative 1. That's 1.8. 1.8, and then we got to pull down our 10 to the 4th. So now 1.8 times 10 to the negative 1 times 10 to the 4th is 1.8 times 10 to the negative 1 times 10 to the 4th. Well, 10 to the 1 times 10 to the 4th is, we add our exponents. Negative 1 plus 4 is 10 to the 3rd. So 1.8 times 10 to the 3rd. Well, it wants us to round to the nearest one. What they mean is the nearest 1 digit. So that's not clear in the exercise. So rounding this to the nearest 1 digit is 2 times 10 to the 3rd. So a proton is 2,000, 2 times 10 to the 3, or 2,000 times heavier than an electron. So that was exercise number 4. And really, again, the whole key is how do you divide? Dividing in scientific notation. All right, let's move on. Exercise 5. So exercise 5 says the geographic area of California is blah, and the geographic area of the United States is blah. So you're trying to figure out how many Californias are going to fit into a United States. So again, here's California, and then here's the United States. So California is clearly, smaller than the United States. So how many of these, if you just kept drawing California over and over and over again, how many would fit into the United States? Well, you have to divide. And they start you off by telling you that the United States is 3.794 times 10 to the 6th square miles. And California is just 1.637 times 10 to the 5th. Now, Engage New York wants you to divide these 4-digit numbers, but I'm going to let you divide 2-digit numbers as I told you in class. So let's round this to 2 digits. 3.8 times 10 to the 6th over 1.6 times 10 to the 5th. So just like we did on number 4, you're going to divide these numbers and subtract these numbers. So 3.8 divided by 16 is 3.8 divided by 16, 1.6. It's the same thing as 16 into 38, right? Because we would move this over and move this over. So 16 into 38 is, it ends up being 2.37 after you do your long division, dot, 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 dot. Well, 2.37 rounds, well, let's just say that that's 2.37 times 10 to the 1st. Now, this number is in scientific notation because 2.37 is between 1 and 10. So, but I'm letting you round this to the 2 digits. So rounding to 2 digits, we get 2.4 times 10 to the 1st, which is equal to 2.4 times 10, or 24. Either answer will do. So the answer is about 24. So about 24 Californias would fit in the rest of the United States. Good. Okay, number 6. This says the distance to Earth from the moon on average is 3.84 times 10 to the 5th. And the average distance from the Earth to Mars is 9.24 times 10 to the 7th. And I tell you that when they're looking for difference, I even told you in class, we're doing a subtraction problem. We're not doing, this is no longer a division. This is the only subtraction problem we had to do. And when we subtract, we have to convert these numbers into real, we have to convert these into normal numbers. So let's take this and let's go 9, 2, 4, and add our zeros. 1, 2, 3, 4, 5, 6, 7. And so 1, 2, 3. So this number is 92,400,000. This number here, let's see, 3.84, add our zeros. 5, 1, 2, 3, 4, 5. So this is 384,000. So this is a straight subtraction problem. So we get 0, 0, 0, comma. Here we have to borrow. So this is a 3, this is a 9, this is a 10, 6, 1, 0, comma, 9, 2. So our answer is 9.2016 times 10 to the 7th. And if we rounded it, you can also say 9, because I think we said we could round this one, 9.2 times 10 to the 7th kilometers. Right, so when we subtract, the key is you can't subtract numbers in scientific notation if they have different exponents. All right, now we got problem set number 1. So problem set number 1 says 7.5 times 10 to the 18th grains of sand on Earth, and 7 times 10 to the 27th atoms. This is grains in the body. And this is grains on Earth. Well, we know that the way that we compare two numbers in scientific notation is we just look at their exponents. And so we know that this is the bigger number because it has bigger because it has bigger exponent. Now, number 2, it says how many times bigger. And I told you, so if it's how many times bigger is atoms in the human body, we would say, well, we say 7 times 10 to the 27th divided by 7.5 times 10 to the 18th. Because how many times bigger? Well, in class and on the instructions, it said you could round 7.5 to 7. And now you might see why. Because you can say, well, that equals 7 times 10 to the 27th over 7 times 10 to the 18th. And that equals 1 times 10 to the 9th. So there are a billion times more, 1 with 9 zeros after it, a billion times more atoms in the human body than there are grains of sand on Earth. Kind of crazy, but seemingly true because they put numbers behind it. Okay, now we're going to finish up with the last questions, and we're going to do number 3 and 4. So number 3 says the area of California. So I'm just going to do the rounding right now. So the area, I'm going to draw a chart, and I'm going to say area and then population. And then I'm going to do California and then the US. So the area of California is 1.6 times 10 to the 5th. And this is square miles. And the population is in people. The area of the US is 3.8 times 10 to the 6th. And in California, we have 3.8 times 10 to the 7th people. Okay, and we don't know the population of the US just yet. They're going to give it to us later, but we're trying to guess the density. So now what we want to find is the density of California. And we know that the density of a substance is its mass over volume, but the density of a people is basically the number of people per square mile. People per square mile, right? So if you had, say, 1,000 people and they lived in 5 square miles, you would have 1,000 over 5 equals 200 people per square mile, right? If you had 1,000 people and you had 5 square miles, we're going to take each of the 200 and put each one of them into each one of the 5 square miles, and you come up with 200. So let's just keep that in mind as we find the density of California. So we're going to say, well, how many people are there per square mile? Well, we're going to say that's our number of people, 3.8 8, whoops. 3.8 times 10 to the 7th over 1.6 times 10 to the 5th. What we know from earlier, and I'm just going to say, we did the calculation, we divided, back here, we divided 3.8, where did we do this? We divided 3.8 by 16 and we got 2.4. So I'm going to reuse that calculation right here. So this is 2.4 times 10 squared. And that's people per square mile in California. So now the question is they say if the same density of people in California exists across the United States. So in other words, if there's 2.4 times 10 squared people in every square mile across the United States, and there are 3.8 times 10 to the 6th square miles in the United States, we would say, well, we need to multiply the number of square miles times the people per square mile to figure out how many people there would be total. Every square mile has 2.4 times 10 squared, 240 people, and there's 3.8 million square miles in the United States. So to multiply these two together, we say, well, we have to multiply 3.8 times 2.4. And if you work out that multiplication, you come up with basically 9.1 after you round it. 9.1. And then this is times 10 to the 8th. So this is how many people in US, if US had same density as California. Now it turns out, so we're going to now switch over to number 4, but it turns out, so I'm going to rewrite that number here, 9.1 times 10 to the 8th. Now it turns out, this is the guess, but the actual number of people in the United States is 3.14. We're going to round that to 3.1 times 10 to the 8th. So how much, how does this compare? How does this compare? We're going to do that. We're going to compare it with division. And so we're going to say 9.1 times 10 to the 8th over 3.1 times 10 to the 8th. And I told you could round this to 1 digit in class. I showed it to you on the board. So we're just going to call this 9 times 10 to the 8th over 3 times 10 to the 8th. And now our answer becomes very clear, which is 3 times 10 to the 8 minus 8 to the 0. So that's equal to 3 times 1, or 3. So the answer is about 3 times. So that's all your answers for today. This should get you through the entire problem set and allow you to be well prepared for tomorrow's quiz. It's tomorrow's quiz, and it's going to cover conversion of scientific notation, multiplication and division of scientific notation, and word problems, of which 2 or so, maybe 3, will be from this problem set that we just worked on. Please send me email if any of this was confusing or you need any extra help or would like any clarification on these problems. Otherwise, I assume you'll be ready tomorrow for the quiz. See you tomorrow.